So remember, if f is increasing, those right endpoints will give the upper sum, as we stated up above, and the left ones will give the lower sum, again, as we stated up above. But if I change that and I make my function be a decreasing function, so there's my curve f of x, then it switches. And so you can see here I've drawn in my vertical widths, my rectangle widths. And so if I connect from the right endpoint, so right, connect over, 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 and right, connect over. Now you can see that the right is going to be too small. Versus if I had done the left. So let's see what the left would look like. So now I want to connect left. I got to think here for the first one. So left over, and then left. Now that's going to be a left endpoint, and I'm going to connect over, and a left, go over and down. That's a left, so I want to go over and down, over and down, left, over and down. And so now you can see that the left is too big. So it's switched. So now this gives me the upper sum. And so what I should have learned from that, though, in both cases, above and below, is that my real area, will the real area stand up, is somewhere between, always, this upper sum and the lower sum. So another idea that calculates have had is, in order to not make that a little bit under or the little bit over so much, in order to shrink that, what if I use midpoints instead? So again, when you draw this, pay attention to, you want these rectangles to all have the same width. So there's my delta x, so that they're all the same width. But now, here's the twist. I want to find the midpoint of each of those rectangles. So if that's their width, then the midpoint in that width would be somewhere here. We're going to call it M1, and the midpoint in this one would be here. We'll call it M2, and the midpoint in here would be M3. And the midpoint in here would be M4, and you get the idea. And so now I'm going to draw up from that midpoint, and I'm going to call that the height of my rectangle. Pretend that's not perfect enough. I've got to fix it. So I want it to be right there. And then this one, again, would go all the way up. And this one would go all the way up till I hit the curve. All the way up till I hit the curve. All the way up till I hit the curve. And same thing here. And so now what I notice is that I have this little teeny tiny bit. There's a little bit over here. I guess that's not a good color to use. We'll try a different color. we'll do this purple. So there's a little bit over in here and a little bit under in here for that first rectangle. But we're thinking that maybe they balance each other out. And then same thing here. There's a little bit over in here, and a little bit under in here. So hopefully they balance out, and a little bit over right there, and a little bit under right there. And then same thing here, a little bit over, a little bit under, a little bit over, a little bit under, a little bit over, a little bit under. But it looks like it's a lot less if I compare to the two diagrams up above. And then of course I want to label the y values. So the x values that I'm using, the heights, are from the midpoint. So the y values, the actual heights, would be f of m1, and this one would be f of m2, and then f of m3, and all the way up to f of m6. And so when I calculate the area this time, notice that the rectangle is still delta x wide. So for rectangle number 1, here we'll label these. So this is rectangle number 1. So for rectangle number 1, the width is delta x, but the height is f of m1. And for the second rectangle, I'm going to shade it in right here. So again, the width is delta x, but the height is f of m2. And I have a feeling you're starting to catch on. So dot, dot, dot. And then we'll look at the last rectangle, this one here. And so the width is still delta x, and the height is f of m6. And of course, if I pay attention to what's changing, I notice that, oh, only the bottom is changing, only those little subscripts. So I could write that area is the summation. Remember, delta x can either go out in front or after the sigma. It doesn't matter. And I like to start at I equals 1 if I can. I'll look at the pattern and see, and I go, oh yeah. Looks like I did start at 1 and I ended at 6. And again, if I don't know how many rectangles, so that's specific to that picture. So generically, I would keep going in with all the rectangles, however many that would be. And so I would say, oh, well, I don't know how many rectangles it's going to take. Because again, it depends on how wide I make them. So it would go from 1 to n. And then I would just do m sub I. So it's a lot of new notation. Take your time, see if you can get your head wrapped around it.